Hello students, welcome back to Turning Point classes. In today's session, I discuss the questions related to Kcet from the third chapter of second PU physics, that is current electricity. Let us start. A wire of length 2 meter is pre-drawn to a length of 4 meter. Then its resistance will, 4 options are given. So, given wire is stretched to a different length. Naturally, there will be an increase in resistance because there is a change in length and there is a decrease in area. Resistance is directly proportional to length. Resistance is inversely proportional to area of cross section. If you use this formula and simplify it, finally we will get the new resistance in terms of initial resistance. This result in the shortcut form, if you remember, it can be done in a short time. I will give you this formula. R dash is equal to n square r. This we should remember. This type of question has appeared several times in previous papers. If you remember, R dash is equal to n square r. R dash is new resistance. R is the initial resistance. Then n is equal to final length divided by initial length. If I apply the given data of the problem here, n is equal to 4 meter is the final length divided by 2 meter, that gives us 2. Put it in R dash. So R dash is equal to 2 square into R, that is equal to 4R. So the resistance has become 4 times the initial value, increases to 4 times. Option C is answer. The next question is 3 resistances 2 ohm each are connected in the form of a triangle. The resistance between any two corners is. Find out what is the resistance between any two corners. I take these are the two corners. I take A, B. Say we are given 2 ohm, this is also 2 ohm, this is also 2 ohm. Just fix the ends across which resistance is to be formed. Then if you rearrange the circuit, so this one is remaining as it is. If you look at the remaining part of the circuit, it is in series. Series is one after the other, hand to hand connection. So hand of this resistor is connected to hand of another resistor and so on. So resistor has got 2 hands, then capacitor also you can think of 2 hands. Hands are nothing but leads here, connecting wires. So here, this hand of or this lead of resistor is connected to another lead and so on, therefore they are in series. We learned in series combination, effective resistance is sum of individual resistances. 2 plus 2, that gives us 4 ohm. 4 and 2, they are in parallel. Therefore, net resistance, use the formula R1 R2 divided by R1 plus R2. So, if I use this, I get 4 into 2 divided by 4 plus 2, 8 by 6, that is nothing but 4 by 3, which is there in option D. Next one, 2 resistors R1 and R2. Of course, R1 is less than R2 is given. They are connected in parallel. What is the equivalent resistance capital R? We learned in parallel combination of resistances, the effective resistance is less than the smallest of the resistances which are connected in the combination. So here R1 and R2 are in parallel. Between these two, R1 is a smaller one. The effective resistance R is less than R1. That is the answer which is there in option D. One more problem. A wire has a resistance of 2 ohm. It is bent in the form of a circle. The effective resistance between the 2 points and any diameter of a circle is. We will take one simple circle. Now, 2 points were taken on any diameter of a circle. So let us say this is the diameter. We have taken 2 points. Now we are asked to find out What is the effective resistance between the 2 points? So if you observe these points, say one is point A, another is point B, the total resistance of the wire is 12 ohm. So resistance is directly proportional to length of the wire. That you might have learnt. R is equal to rho into L by A. So R is equal to rho into L by A. This is the formula what we have. So resistance is directly proportional to length of the wire. If you observe AB upper part and lower part and lower part, they are equal in length. So therefore, the complete 12 ohm resistance of the wire is divided into 2 parts. Upper part has got resistance of 6 ohm, lower part has got resistance of 6 ohm. Now if you observe between these 2 points, this wire, they are connected in parallel. So parallel connection. So this is one resistor. So let us think that this is one resistor like this. This is also one resistor 6 ohm. When 2 resistors are connected in parallel, of course each of them have identical value. Shortcut formula is Rp is equal to R by N. So when N identical resistors, each of resistance R are connected in the capital R. Each of resistance capital R are connected in parallel. Net resistance in parallel combination is given by R by N. Now for this one, Rp is equal to R is nothing but 6. There are 2 such resistors connected in parallel. 6 by 2, that is equal to 3 ohm. There is the answer. So option D is answer for this question. The next one, 2 resistances are joined in parallel whose resultant is 6 by 5 ohm. One of these resistances wires is broken and the effective resistance becomes 2 ohm. Then the resistance of the broken resistor is. Just to understand, it's a very easy problem. Say we are given 2 resistors. This combination, when they are connected in parallel, this combination has a resistance of 6 by 5. So one is R1, I will take this is R2. So Rp is equal to, formula is when 2 resistors are connected in parallel, Rp is equal to R1 R2 divided by R1 plus R2. What is given? This is given as 6 by 5. So this is given as 6 by 5. Now in the next line it says if one of the resistances is broken, say one R2 is broken, then the effective resistance becomes 2 ohm. That means when R2 is broken, there will be only one resistor. So that is R1. So indirectly it is given the value of R1 is 2 ohm. Or you can take R2 is equal to 2 ohm. When one of the resistors is broken, only one wire is left out. Now if you find the effective resistance, that is given as 2 ohm. Let me take R2 is broken. Then the second line says R1 I will take it as 2 ohm. Now we are asked to find out what is the resistance of the broken wire. Come back to this and substitute R1 is equal to 2. 2 into R2 divided by R1 plus R2. R1 I replace it by 2 plus R2. This is equal to 6 by 5. So simplification. 2 3 times go for cross multiplication. 5 into R2, that is 5 R2. This is equal to 2 into 3 is 6 plus 3 R2. Bring 3 R2 to left hand side. Then we will have 2 R2. This is equal to 6. R2 is equal to 3. This is the answer. So R2 is equal to 3 ohm. Option D is the answer for this one. The next question is there is a current of 4.8 ampere in a conductor. The number of electrons that cross any section normal to the direction of flow. It is the direction of flow of current per second. So I is equal to Q by T, that is familiar to us. Q is nothing but Ne, that is in properties of electric charge, that we should recall. Of course we discussed in the first chapter itself. So if you have not watched those videos, link is provided. Go to that link, view all previous videos, then you can understand these topics in a better way. I want what is N. If I write for N, this equation, so N is equal to IT by E. I is given as 4.8 ampere. T is nothing but 1 second. In 1 second is given divided by E charge of electron 1.6 into 10 power minus 19. Simplify. So this is exactly 3 times. 3 into, so you can take it as shift the decimal both in numerator and denominator by 1 position. This is 48. This becomes 16. 48 by 16 is nothing but 3. Bring this 10 power minus 19 to numerator, you get 3 into 10 power 19. So option C is the answer for this question. With this I end today's session. If you are not subscribed to Turning Point classes, subscribe, share the link with your friends, and like the video. We'll come back to the next class. God bless you.